Hello students! In this video we're going to be looking at something called a geometric translation. You've learned about translations before in other math classes along with reflections and rotations and maybe even dilations. Together these are called transformations. So a translation is just a specific transformation. I think the translation is a nice introduction into transformations because it's pretty simple. A translation is a transformation which slides each point of a figure the same distance in the same direction. So we could take a simple figure, like a heart, and slide it the same amount. Each point slides the same amount, and it produces a congruent heart. Let's see what it looks like on a Cartesian plane. First, I've got triangle ABC right here, and I've already listed out its points. We want to take this triangle and we want to translate it 1 unit up to the right and 4 units up. 1 unit to the right and 4 units up. I think the easiest way to do this is to just count. So let's start at point A, count 1 unit right and 4 units up, and put a point. This represents the new location of A. This is the point 2, 1. Let's do B next. Start at B, count 1 unit right and 4 units up, and put a point. This represents the new location of B at 4, 4. And finally C. Start at C, count 1 unit right and 4 units up, and put a point. This is the point 5, 2. Okay, next I'm going to label my triangle and connect all the dots. This would be the copy of A. Up high is the copy of B. And here's the copy of C. We use this little tick mark to denote that we're making the copied image. This is not the original, it's the copy. So when I connect the dots, I'm going to see a congruent triangle that has been copied from the original. It has been slid 1 unit to the right and 4 units up. By sliding each point separately, we've slid the entire shape. That's the visual way to work this. There's also an algebraic way to do this, and it's all about pattern finding. Take a look at each x value. What is the change from the original x value to the new x value? How do we get a pattern out of 1 to 2, 3 to 4, 4 to 5? Well, we've added 1 to each x value. By taking the original x value and adding 1, we have moved this triangle 1 unit right. So this x plus 1 matches moving the triangle right 1. Now let's check out the y values. What's the pattern to go from -3 to 1, 0 to 4, -2 to 2? We've taken every y value and we've added 4 to it. This is the algebraic way to say up 4. So we can come up with a rule that's much more algebraic, or we can do it visually. Okay, let's check out example 2. Example 2 says triangle JKL has coordinates 0, 2, 3, 4, and 5, 1. Step 1, draw triangle JKL. I'm going to pause the video, take a moment, and draw your triangle. All right, check and see if your triangle JKL is in the same location as mine before we begin the translation. Part B here says, draw the image of triangle JKL after a translation of 4 units to the left and 5 units up. Okay, so I'm going to switch up colors here so we can make a clear difference. Our original triangle I've done in pink. and I'm being asked to translate each point 4 units left and then up 5. I'm going to start with J. 4 units left, 1, 2, 3, 4, up 5. 1, 2, 3, 4, 5, plot a point. The translated location of J is -4 and up 1, 2, 3, 4, 5, 6, 7. -4 and up 7. Repeat the pattern to find K. If we move K 4 units to the left and up 5, it would land at the spot -1, +9. Finally, find the new location of L. When moving L 4 units to the left and up 5, the new location is 1, 6. See if you can look at the numbers here to come up with a pattern for the general rule. What would we do to X and what would we do to Y to change each point? If I look at the pattern to get from 0 to -4, or 3 to -1, or 5 to +1, I would take my X values and subtract 4. This takes care of moving the picture left 4. The Y values go from 2 to 7, 4 to 9, and 1 to 6. I'm adding 5 to each Y value. That's due to moving the image up 5. We want to be able to come up with a rule that's good for any point that lives in this translation. Flip over with me and let's check out example number 3. Okay, in example number 3, I have already graphed both the image and the pre-image. Our pre-image is here at LMN in quadrant number 3. LMN has been translated to this location, and that's denoted by these tick marks. This is how you can tell which one the original is and which one is the image that's been copied. So our directions here say, write a general rule which describes this translation. So I'm going to use a couple different colors here to help me come up with a rule. There's really 2 ways to do this. One way is to write out the original point and the image's point. So point L is at -5, -2. Its image is at the point over 1, up 0. All right, now for M. M, the original M is at the point -3, 0. Its image or its copied location is 3, 2. And then finally, point N, the original is at -1, -1. The copied location is at 5, 1. By writing each of the points out, we can then try to find the pattern. What's happening to X to get from -5 to 1, -3 to 3, and -1 to 5. If I follow through on this pattern, I am adding 6 to every X value. Now let's take a look at the Y's. What do we do to get from -2 to 0, from 0 to 2, and from -1 to 1? Every Y value has been increased by 2. So I write my rule as X plus 6, comma, Y plus 2. Now that's one way to do it. You can look at the points and write up a pattern rule. Another way to do it is more visually, looking at the graph. How do we get from point to point? I'm going to start here at N. I move to the right 1, 2, 3, 4, 5, 6, and up 2. Right 6 and up 2. Now, hopefully every point has moved the exact same amount, And if so, that can become our pattern. Let's check out L. 1, 2, 3, 4, 5, 6, up 2. And M. 1, 2, 3, 4, 5, 6, up 2. So every piece has moved right 6 and up 2, and that can be written in this general rule. Right 6 is the same as x plus 6. Up 2 is the same as y plus 2. Okay, for our fourth and final example here, we're going to work on something called a composite function. A composite function. A composite translation takes multiple steps. Let's look at our steps here. First, we're going to graph a triangle. Then we're going to translate that triangle. We've got the rule here to tell us what to do, but we're going to write what we do in words. We're going to draw the new triangle. Then we're going to take those coordinates and translate again. So a composite translation is multiple steps. Let's start with step A here. Graph the points T, U, and V. Connect the points to make a triangle. Okay, I've completed step A. I've plotted the points to create the triangle. Compare ours together before we move on to the translation. Step B says to translate triangle TUV using the rule. Okay, so using the rule, we want to take every x value and subtract 3. Take every y value and subtract 1. All right, so the t would move to 0 minus 3 is negative 3. 3 minus 1 is 2. So the new location of t, maybe I should change colors here. The new location of t is the point negative 3, 2. Let's plot that point. Negative 3, 2. Now for u. Take the x value, subtract 3. Take the y value, subtract 1. 2 take away 3 is negative 1. 4 take away 1 is 3. So our new location of u is negative 1, positive 3. Take a moment and find v. Following the subtraction, 5 take away 3 is 2. Negative 1 take away 1 is negative 2. So my location of v is 2, negative 2. So take a look at each point. Let me label them here. And let's say in words what we really just did. How do we get from the original t to the translated image? How did we get from the original u to the translated image? How did we get from the original v to the translated image? Well, all we have to do is count it out. To get from each point, we went down 1 and left 3. Or left 3 and down 1. So that x minus 3 in words is left 3. The y minus 1 is down 1. I want you to pick out which way speaks best to you. Do you like the math version, the algebraic version, or do you prefer the visual way, just counting it out? Let's draw our new triangle here and make sure it came out congruent. One thing you want to make sure of on all of your translations is that the image remains congruent. All you've done is moved it, but you haven't changed its size. So our new location of each point is negative 3, 2, negative 1, 3, and 2, negative 2. Now, that translation was just like any other. Here comes the composite part. Step F says that we're going to use the image of triangle TUV. So we're going to use these points I have in purple to perform an additional translation using this rule. I'm going to stop the video. I want you to do this any way that you find best. If you prefer counting, then do that. If you prefer subtraction, then do that. But let's come up with the final location of T, U, and V. Okay, no matter which way you prefer to work this problem, I hope you came up with these three coordinates. T lands at the final spot of 0, -1. U lands at 2, 0. And V lands at 5, -5. Thank you for watching my video. Happy studying!